So we are continuing our data analysis course, and as we were discussing Tableau, so we are having this Tableau discussion. So in the previous videos we learned about creating basic graphs. We also have this Udemy course, so I will provide you access to this Udemy course, like you have joined me from WhatsApp, and those who will view this on YouTube, they can simply go and enroll in the course. So today our topic will be how to create a line chart in Tableau. Okay, and we will also discuss when to create a bar chart and when to create a line chart, as this is your question also, right? So the data set that we are going to use is again going to be the same sample superstore data set. Now before starting, there is a very simple rule that we can follow. Okay, so when we have data, since our beginning we have discussed that data is of two types: qualitative and quantitative. First of all, is this classification clear to you? Tanvi?
Yes.
That right? Now the qualitative data is also of two types, that is nominal and ordinal. Okay, and quantitative data is also of two types, that is discrete and continuous. Okay, now nominal variables are variables like blood group, okay, gender, or something which has only a definite set of values. There are only some values possible. Okay, like in blood group, it will be either A positive, O positive, AB positive, or something from a finite number of values, right? Finite number of predefined values. Same goes with gender, and same goes with, there are many such examples. Okay, so in the data set that we have studied so far, in these data set, if you see segment, right? So there are only three type of segments: consumer, corporate, and home office, right? There is no fourth value possible.
Yes.
And similarly, there is region: south, west, east, and central. Okay, south, west, central, and east. They don't have any fifth value possible. Okay, so these type of variables are nominal variable. I am writing region and segment here.
Okay.
Okay, etc. So in our data set. Now there is also some ordinal variables. Ordinal variables also have finite number of values, but these ordinal variables have a order also. For example, highest qualification. Highest qualification can be, let's say in India, it will be 10th, intermediate, graduation, post graduation, doctorate, something like that, right? So it has an order, isn't it? Right? So something
Mm-hmm.
that has a finite number of values, but it has an order. For example, if you are going by train in India, and I ask you, what is your, you know, what is your seat uh, category, something like that, like based on your ticket price. So you will say it's a general class. What is your class of travel, right? In which class are you traveling? So you will either say 3 tier AC, 2 tier AC, 1 tier AC, sleeper, general, right? So there are only finite number of classes available in trains, but they also have an order. Like first AC is a lot more costlier than third AC or sleeper, right? So I'm writing train class. Okay. Same goes to flights also. Same goes to ships also, cruise and ships. So why are we talking about this? When these type of variables are taken into account along with one quantitative continuous variable, okay, then we create a bar graph. Okay, do you get this? We
Can you
create
repeat once more?
we create a bar graph when these variables are when we want to visualize one of these variables and one of these variables, continuous variables. In that case, it will be a quantitative variable, like as I said, it will be some aggregate function, right? Some aggregate function applied on a continuous variable. Like for example, sum of sales. Sum of sales is what? Sales is a continuous numerical variable and sum is an aggregate function. And this aggregate function, when applied on this, we can, sum of sales will be different for different segments, isn't it?
Yes.
Right? Number of people traveling in a train. So count of people, count is also an aggregate value, right? So count of people or count of passengers, okay? Count of passengers traveling in a train per class. So in general, there will be, let's say, 1,200 people. Okay, in sleeper, let's say there are S1 to S10, those bogies, right? So in that case, you will have 720 passengers seats, right? In first AC, you will see in a train only one or two first AC, compartments are there, right? So, so you have to think that like 2 AC is 2 or 3, 3 AC is 3 or 4, and most of them are either you know your general class bogies or sleeper class bogies. Okay, because most of the people can afford those tickets. There are some trains in which there are only third AC compartment or only first AC, so their ticket prices are also higher. So the thing is, yeah, you have to think of, as per your data, that if in your data you have a qualitative variable, it can be from nominal or ordinal section. It can be from any of these classifications, but when it is plotted against an aggregate function applied on a continuous variable, okay, so in that case you will create either a bar graph or a pie chart. Okay, that is the case where you plot a bar graph or a pie chart, because it will. So let's try to create one. We can go to Microsoft Excel and data set. Let's open sample superstore here. In sample superstore, we will drag orders and go to sheet. So when you put segment here, so it is a nominal variable or not? First of all, let nominal or ordinal variable?
This is nominal.
Nominal. There is no such order here, right?
Yes.
And suppose the second variable is also a nominal variable. So in this case,
Mhm.
you will only see a data like this.
This is
Or
a text graph, I think.
yeah, it will only
So,
create text graph because you know in this case you cannot create uh, any type of graph because no numerical data is there. Okay,
okay.
but if you take one nominal variable and one uh, measure from here, sales, then you will get a bar graph because it will be segment wise sales, right? So when there is a
Yes.
nominal variable, you already have grouped the data, you already have selected only distinct values. Okay, and since you have selected only distinct values, so then you have to group the data. This is group, right? Consumer is one group,
Mm-hmm.
corporate is one group, and when there is group, then in order to analyze a numerical variable, you will put a you know uh, you will put a value, and then this value will be aggregate. Okay, we can use other variables also, like it is currently sum, but we can take average. Okay, you can see average sales amount is more in home office. Okay, but sum of
Mm-hmm.
sales amount is more in consumer segment. So
Consumer.
why is this? Because consumers are more than offices, right? So collectively consumers will order more items. Okay, but if home, if office will order something, its order value will be higher. So consumers have bought items worth $223.73, their average value, and they have bought 240.97, right? So this is kind of a differentiation that you can see here. Now similarly there will be minimum, right? So as you can see, even the minimum value of order or minimum sale in home office is close to $1, right? We also then have standard deviation. We also have variance, which we will study later, like what are these statistical measures. So we will study them. So this is when we create a bar graph. So if you will use this combination, like you take one nominal variable, it can be city also because city names are also finite number of city names here, right? And then suppose you take another continuous variable which is quantity. So you will see it is a bar graph. Okay.
Mm-hmm.
In those situations or in those cases when we create a bar graph, those are also the cases when we create a pie chart. Okay. So for example, for the same combination, like if we take segment and if we take sales, we can also create a pie chart. Okay. So for pie chart
Yes.
also there is this similar condition. But in case of bar, as you say, as you are asking, like technically, if we only take one measure, for example, sales, if we only take this much, then also one bar graph will be there, right? But
Mm-hmm.
the, I don't think this bar is very useful because it is only representing one single value. So a better option will be to have a text value, right? Which will actually
Yes. Yes.
display that number. There is no point of having a bar with only one bar, right? Bar is more useful when you have things to compare, when you want to see, like which is the highest, which is the lowest, right? So when you have finite, your answer, when we have finite number of values, right, then it's a bar. Similarly, there is one more case where bar graph will be uh, a suitable type of graph. So if we drag order date here, okay, now you have to listen very carefully. When we drag any date value in column or in row, okay, doesn't matter. So what is the color of this? Blue color, right? And with blue color we associate blue color with dimensions, right? Yes or no?
Yes.
Right? So in this case, this 2014, 15, 16 and 17, it is not a numerical value. Although it's a number, but it is not a numerical value, right? It
Yes.
is just a label. If you will call it 2014, yeah, if you call it 2014, it will not make any difference, right? Because it is 2014, right? And in this case, if you want to see profit in all these years and you create this, okay, then actually bar will be a suitable graph, right? Like how profit increased or how sum of sales increased throughout the years. Okay, do you get this point?
Yes.
Right now, but when I created this graph, by default it created a line graph. Okay, so when you have to create a line graph, now let's come to line graph. So the most ideal condition to create a line graph is on x-axis we have a continuous variable and y-axis also we have continuous variable, continuous numerical variable. Okay, both on x-axis and y-axis we have a continuous variable. Okay, and in most of the cases this continuous variable will be some value of time related variable. What are time related variables? Date, date, time, or simply time in seconds,
Time. Yes. Yes.
right? Or intervals also, like 1, 2, 3, equal intervals.
Yeah.
It should be equal, right? Equal intervals. So we should have some equal intervals. If we have those equal intervals, then we can create a line. So on both axes we have continuous variables, okay, and it is actually used to compare if we increase one variable, okay, then what is the effect of that variable on the other variable. Okay, for example, let's say we did a experiment where we were measuring voltage and time, voltage and current. Okay, so when switch on a fan, for example, in fan also you have a regulator, right? Speed regulator, you have that, right? So what happens is, with that regulator you can actually control the speed of fan, right? So this is also, we can vary the voltage across a load. So let's say when voltage was 200, then it was 220, then it was 240, then it was 260 and 280. Okay, so current was 1, 2, 3, 4 and 5. I'm just giving a very basic situation. So in this case, if you will plot a graph, how what will be the best way to plot the graph? What we will do is, you take you mark it like this. Okay, on x-axis you will mark 200, 220, 240, right? This is how we used to plot graphs, right? 260, 280,
Yes.
right? And then here you will write 5, 4, 3, 2, 1. So I'm just writing it, okay, something like this. So when voltage, let's copy this, go to our graph and paste it here. Okay. So when voltage was 220, current was 1, right?
Yes.
So what you will do is we are taking a very thin line. So this is 200. This is where voltage. This is a line where voltage is 200, and this is line where current is 1. So this is 1 point, right? Similarly, when it is 220, voltage is 2, right? When it is 240, voltage is 3, right? When it is 260, voltage
Mm-hmm.
is 4. Because you ask in which situation we create line graphs, right? It is 5. Okay. So these are our actual points. These are our actual points. Okay. So I'm just taking a brush. This is 1 point. This is second. This is third. This is fourth, and this is fifth. If you will actually, because we have not used these things, but if you will actually join them, this is a straight line, isn't it?
Mm-hmm.
Right? Why is it
Yes.
a straight line? Because it is like that. It
Increasing.
yeah.
It's
So when you are
increasing
increasing
proportion.
voltage, current is also getting increased. So whatever is our independent variable, like voltage in this case, we put that variable on x-axis. Okay. So this is our independent variable, and whichever is the dependent variable, like current in our case, okay, and this current is our y-axis, right? Because when we increase voltage, then we see its effect on the y-axis. That's why there is a formula called y is equal to mx plus c. Have you ever heard about this formula, mx plus c?
Yes. Yes. Yes.
This is
Yes.
equation of a straight line. This is for the straight line. I will come to line graph later, but this is equation of a straight line. Here C is 0, because when voltage is 0, current is also 0, right? Like if you extend this line,
Yes.
right?
Mm-hmm.
So here C is 0, that's why the formula becomes y is equal to mx. And we can actually calculate value of m here. M is tan theta. Okay. It's the angle
Yes.
of angle that this line makes with the x-axis. This will all come handy later when we will do trend analysis and linear regression analysis. But the concept is, when there are two variables and by increasing or decreasing one variable, there is some effect on the other variable. Okay, both are numerical. Like current voltage is also numerical, current is also a numerical variable. Okay, so in such
Mm-hmm.
cases we can create a line graph. Okay, or we have some kind of intervals here. We can say this is interval of voltage, right? When first interval, second interval, third, fourth, fifth. So in such cases we create a line graph. So as a beginner you should remember that when, like, we cannot create a graph between sales and profit, you know, we cannot do that. We cannot create a line graph. If you will try to create a line graph, you will not be able to create one. It will be like this. Okay, so
Mm-hmm.
line graph will be possible. Profit and sales line graph is possible. Like when profit increases, does the sale also increase, or vice versa, right? So you can compare, but this is not, this should not be done, like we should not do that. But when we have order or date or time related value on one axis and a numerical value on the other axis, okay, so in such cases line graph is an ideal graph. Okay, do you get this?
Can you repeat this last phrase once more? I'm just
When
making.
when when any time related variable is on x axis, okay, any time related variable is on x axis, then and we have a continuous variable on y axis, a continuous numerical variable on y axis. In such cases we can create a line graph. Okay, when we have a
Yeah.
dimension on the x-axis, okay, when we have a dimension on the x-axis and a measure, continuous measure on the y-axis, then we should draw a bar graph. Although we will have
Got it.
some exceptions later, but for you to remember, dimensions plus continuous measure bar graph, right? Time variable or continuous variable or continuous measure plus another continuous measure, line graph. So we will drag order date. Now I will come back to my question. What is the color of this? Blue, right?
Yes.
Blue
Yes.
means summary, dimension, grouping, right? Summarization of things. Okay. So date is something that can be changed. This is year. You can see, right? So I'm showing it once again. Just see it carefully. When you will click on it, you have year, quarter, month, day, more. Okay. You have year, quarter, month, day, more. So date is something that can be considered as a dimension also and a measure also. Okay. When you will consider it as a dimension, it will be more like a summary. Okay. And when you will consider it like this, it will be more like a number. Okay. Do you get my point?
Yes.
Okay. So I am selecting year here also. Okay. Now what happened? The interval increased. Now when you will drag sales, right? So you will have this type of data. What I can do, I can select quarter also. This is quarter wise sales. So you are seeing now quarter is very interesting way to compare all of this. How many quarters will we have in 4 years?
Well,
So every year we have 4 quarters. That is why it is a quarter, right?
16.
Yeah. So this is data of 4 years. So you will see 16 data points here. Okay, right?
Yes.
This is when we have selected this quarter, like the quarter as a measure. Okay. When we have selected quarter as a dimension, then we have only 4 quarters, because in total there are only 4 quarters, right? Here we are not considering years. So it is summarizing the
Yes.
data. It is summarizing, like it is adding, for example, quarter one in all the years combined, quarter two in all the years combined. So if we just have to see which quarter performs well, like we have 4 quarters, which quarter performs well, we can use this blue graph, right? Quarter as a dimension. But if we have to see which quarter in which year performed best for us, then we will select quarter as a measure. And when we select quarter as a measure, we can see that the quarter of 2017, the fourth quarter of 2017 had most number of sale or most value of sales, right?
Mm-hmm.
We get this point. So this is where we create line graph, right? Line graphs. Why are we creating line graphs? Because first of all, it is a variable of time, and on y-axis we have a variable, a continuous variable. Okay, and
Yes.
but you can also summarize. You can also visualize this with bar graph also, right? So line graph and bar graphs are also interchangeable sometimes. That's why they are confusing also. But as I told you, if
Mm-hmm.
it is something related to time, just draw this line graph. Okay. And if he,
Okay.
it is,
Yeah, that was my question actually. Means if
yeah,
it is time related, then we will choose the line graph. And if
yeah,
it is not time related, then we can choose the normal side by side bar
normal
graph
bar
or
graph.
something like
Yeah. Because time related shows that time is increasing. So it is something continuous. So the same answer, if you are using a continuous variable here, okay, a continuous or a measure here, even if
that.
you are using date as a measure here, then line graph should be preferred. If you are choosing it as this graph, then for me bar graph is the
Yeah,
better,
dimension.
right? So when it is blue, B for
Got it.
blue, B for bar. We can, I know it is not, you know, best way to remember this, but you can do this, right? So, and even area chart also is very similar. So
Okay.
when we create a line graph like this, we can also choose area, right? Because area chart just shows the area under the curve, right? And what is a curve? A line
Mm-hmm.
is actually a curve. Okay. So line will line will always not be a straight line. It will be a curve also. Right? It can be parabola, hyperbola. It can be circle, anything it can. So
Mm-hmm.
this is something that you are area chart you are showing here. Okay. So this is area under the curve. So when you have created a line graph, you just do this. And here you can see for lines discrete, you can see that. For lines continuous.
Yes.
Okay. Yes. So lines as discrete. When you will choose lines discrete, it will create line graphs. Okay. But for all 4 years. This is discrete well. Like in case of,
Separately, it will be
yeah,
there.
separately. Like years are separated now, right? All years are separated. But when it is a continuous variable, like what is continuous? Like end of
There will be
2014
no
is,
interval. There will be no
yeah,
interval
there will be no
between
discretion.
two
There will,
values.
yeah, there is no
Oh,
discretion. Right? End of 2014 is beginning of 2015. So there is a continuation, right? Like when 2014 ends, immediately
mm-hmm.
after that 2014 starts. So it's a continuation. But if you are considering these years as discrete, then also you can draw line graphs. But this will be like 2014, 4 different quarters, 15, 4 different quarters. So this is how it is divided. That's why your understanding of, that's why whenever we teach someone, first day we tell these things like you have to understand nominal and ordinal variables and discrete and continuous variables, because same thing you can consider as discrete in Tableau, same variable you can consider as continuous in Tableau. It totally depends upon the question also, but this is what you can do. Okay, now very important thing, here we are comparing sales of all the years combined, like a continuous variable. We want to see our growth. Okay. So when people will ask you questions like forecasting, like, you know,
Mm-hmm.
what is your projected
Prediction.
prediction? What is your projected sales? What is your projected profit? So in that case, you actually have to present the graph in this way, right? Both of them should be
Mm-hmm.
continuous, right? Not discrete, because then only you can predict something, right? Because you will analyze this trend, and on the basis of this trend you will predict the next value. Like, okay, now we see that it is going up, so we can predict that, okay, by how, what will be the percentage increase or percentage difference. Okay, so in Tableau there is a tab data, there is another tab analysis or analytics. Okay,
Yes, yes,
so
analytics.
in analytics there is a model called forecast. Okay,
Okay.
so when your graph appears like this, you can go and forecast. Okay, and this will
Okay.
generate an estimated interval for you. Okay, we will learn more about forecast later, because there will be a separate lesson on forecast. But I'm telling you why creating a graph like this is important, because it helps in
Mm-hmm.
forecasting, trend analysis. You can also draw this
Mm-hmm.
trend line. This trend line, what is the trend line? When I will teach you linear regression, basics of linear
Mm-hmm.
regression, then I will teach you like what is the use of trend line. Okay, but this trend
It's in
line,
layman language. Is it in increasing or decreasing? What is the pattern
exactly,
it's following?
yeah, trend line is the line of best fit. Okay, like it in see, ideally this increase should have been linear. Okay, ideally, let's say,
Mm-hmm.
but
Mm-hmm.
it's not linear, it has peaks and valleys, right? So this trend line is actually kind of compensation of those peaks and valleys. It's an average line, right? if
Yeah, yeah.
if
I
there
was
were
about
no
to say
peak,
this.
yeah, so if there were no peaks in value, like what would have been an average ideal line to represent, you
Mm-hmm.
know, sales by year. So this is that line. Okay, so this is that graph. So you will create this graph also. Here also we can do forecast, and here the forecast will be a discrete forecast, right? So it's like, because you have represented them in a discrete way, so it is predicting
Mm-hmm.
like for 2018 what will happen, right? So this is, both of them
Yes,
are,
yes.
both of them will be required. Like someone might ask you to present it in this way, like, okay, we did in 2014, we did how we did in 2015. Based on the same trend, what will be the case in 2018? But if someone says, no, I want the forecast, looking at the whole picture, I want the forecast, like considering as a continuous value, it will be like that. Okay. So this is what we will do. And by the way,
Mm-hmm.
these are the
Okay.
models, which you will learn: trend analysis, forecast, and cluster on many other data sets. For at least going through things one time, we are learning with the help of the sample superstore data set. But you can do exploratory analysis on many such data sets. Okay, One of them is the
Mm-hmm.
Northwind data set that I have given you.
Yeah, I was
And
practicing with that
yeah,
one only. I just share
yeah,
you some screenshot of shared and the data set which you given for
yeah.
the not.
And there is Seaborn GitHub data set. Okay. So we have this GitHub repository. In this GitHub, I will share this link with you. In this GitHub repository, there are these CSV files. Okay. So
Yeah, yeah.
here we have one good file is tips Titanic penguins. Okay. So this tips data also has two continuous variable like total bill and tip. Okay. So for
Okay.
example, what is this data? So this data is of a restaurant where the restaurant owner kind of noted down the details, right, of a person
Mm-hmm.
eating, that whether person was eating dinner or lunch, okay, whether on which day person was eating, whether the person was a smoker or not, and the person who paid the bill, was the person male or female, what was the total amount of tip received, what was the total bill. Okay. So now there are many questions that can be answered through this data. Like, can you tell whether a smoker, you know, paid most bill or non-smoker? Okay. Which was
Mm-hmm.
the day
Mm-hmm.
on which most number of customers came? Okay.
Mm-hmm.
Whether more people came for dinner or for lunch. Okay. What's the average
Mm-hmm.
size of what's the average size of one customer, like, because in some cases it is
One
two, some cases
family.
what
Family,
is
yes.
the average size of, yeah, customer, right? And what if we increase total bill, does that increase tip also or not? Okay.
Mm.
Like, can you tell that? Here straight line will not be possible.
No, no.
Be-
Here in this case, not possible.
yeah, right.
Means it
So
should be a combination of things in a very discrete
yeah,
way,
yeah,
not a continuous way.
yeah. So in such cases, you know, in such cases, scatter plot is the best plot to create to compare these
Okay.
two variables. Okay. So we will learn exploratory analysis on tips data, but what you
Mm.
can do from your end, you can download this data, there is an icon, and you can do exploratory data analysis, right? You can,
Okay.
like, you can just freely explore the data. I have asked many questions, right? Like, just try to answer this question, like, who do you think paid more bill, female or male, right?
Mm.
Who gave more tip, female or male, smoker or non-smoker, on which day we got. So whenever you will get data, it will be always like this. Here total bill is
Mm-hmm.
continuous, tip is continuous, size is a discrete value, okay, and all
Mm-hmm.
these variables are female, smoker, time and day. All these variables are nominal variables, okay.
Mm-hmm.
If you compare with this sales data, you will see a pattern, right? Although we are comparing two different things, but there is a
Yes.
pattern.
Yes.
Now, what is the objective of this? The objective of this particular problem is, if we have two people, we are eating dinner at dinner time on Sunday, we are non-smoker, and bill pair is female, and if total bill is around $17, what tip should this person give to the waiter, right? So it's actually a
Yes.
problem to calculate tip by using machine learning algorithms. Okay. So we will use
Mm-hmm.
many machine learning algorithms to calculate this. So uh, this is done with Python and all, but with something like Tableau, we can actually explore this data. Same
Mm-hmm.
happens with Titanic also. In Titanic, the output variable is survived, right? Whether the person will survive or not, if the person is female of class 1, like what are the chances, right? So you have to calculate it through data, right? Through data analysis, like some kind of conclusion you can make. So this is also a good data to explore. Okay, I have created many videos also on my channel where I have done exploratory analysis on Titanic, and there are many such cases. So as a revision, you can do that. Like as a practice, you can use this also. This will help you in getting more familiarity with Tableau and graphs and all, right? So,
Mm-hmm.
so this is our graph.
Sir,
Okay.
can I complete that not to that one first and then go with this one, or do you want me to do this one first?